Right friends, welcome back to News Analysis. This is about a cosmic revolution, what Albert Einstein thought 101 years ago could be measured after 101 years. So the theory of Albert Einstein became a reality after 101 years. So gravitational waves were detected for the first time, and before understanding what is meant by gravitational wave and how they are produced, you have to know a little about the universe. What is universe? Universe is nothing but the amalgamation of various galaxies. In the observable universe, up to what extent universe is there, no one knows, but in the observable universe, there are around 170 to 200 billion galaxies, and please don't forget, our solar system is part of Milky Way galaxy, and now this universe includes planets, stars, galaxies, and the observable universe is around 28 billion parsecs or 91 billion light years in diameter. Parsec is the unit used to measure lengths beyond our solar system. Beyond our solar system, in the observable universe, if someone wants to measure the distances up to stars, then the unit used is parsec. 1 parsec is more than 3 light years. So the observable universe is about 28 billion parsecs in diameter at present time, and the total extent of our universe is still not known to humanity. And before understanding these gravitational waves, you should also understand the concept of space-time. And please don't forget, the space is not static. That means it is not rigid. It is flexible. Why it is flexible? It is flexible because of several astronomical events taking place. Various planets revolve around the sun, then several stars are burning out, the process called supernova, to form neutron stars. Several black holes are colliding. That means the universe is not static, it is dynamic. So the fourth dimension is added here. The 3 dimensions of space, all of you are well aware. The fourth dimension is time. That means the universe is not rigid. So as to identify universe as a dynamic event, to identify it as a flexible entity, the fourth dimension, time, is added. So that's why if someone talks about universe, please look at it from 4-dimensional figure. That means 3 dimensions of length, width and height. The 4th dimension is time. That means it can be distorted and warped as the large masses accelerate and move through the universe. Right? So this is about the 4 dimensions of space. Next one is galaxy. I have already told you, several billions of galaxies make universe. Several billions of galaxies. Each galaxy consists of gravitationally bound systems of stars, then black holes, then dust, dark matter. These are part of a galaxy, and our galaxy is a Milky Way galaxy, and our solar system, that is the sun and the planets, is a part of Milky Way galaxy, and billions of this type of galaxies will make the universe. Right? And after this, if you want a black hole, what is meant by black hole? Black hole is nothing but it exhibits strong gravitational effects due to which particles and electromagnetic radiation cannot escape from it. It acts like an ideal black body because the black body does not reflect light. Similarly, this black hole does not allow these particles and electromagnetic radiation come out of it. Right? And it continues to grow. These black holes will continue to grow by absorbing mass from surroundings, and when 2 black holes collide, the reduction in the mass will be released in the form of gravitational waves. Right? When 2 black holes collide, the reduction in the mass will be transformed into gravitational waves. All of you are well aware, energy is equal to mc square. M is mass into speed of light square. So, when mass is reduced for these astronomical objects, then that will be dissipated in the form of energy, or you can say gravitational waves. That what we have measured on the ground. If you look at the neutron stars, these are the stars formed due to the gravitational collapse of massive star after supernova. Supernova is the process where stars get collapsed, and after the collapse of these stars, these neutron stars will be formed, which compose entirely of neutrons, and these are the densest and the smallest stars known to exist in the universe. And what are gravitational waves? As I have already told you, in the universe there are several black holes, there are several stars, there are several neutron stars, and the black holes will collide with each other, and at the same time stars will explode, the process known as the supernova, and because of these actions in the universe, the energy will be dissipated in the form of gravitational waves, causing ripples in the universe. These are gravitational waves. These are the ripples in the fabric of space-time. I have already told you, you have to view the universe as a 4-dimensional entity, that is the 3 dimensions plus time, and these gravitational waves are the ripples in the fabric of space-time that are produced when black holes collide with each other and stars explode. Or you can say gravitational waves are produced when objects accelerate in the universe. And these gravitational waves were first proposed around 100 years ago by Albert Einstein as part of theory of relativity, and at the time he told they are too weak to measure. Our scientists have developed the most sensitive instruments after several years of trial and error. With the combined effort of around 100 scientists from 15 countries, this finally became a reality. And if you look at the gravitational waves, how they are produced. If a star explodes, what we call a supernova, gravitational waves carry energy away from the detonation at the speed of light. When a star explodes, gravitational waves carry energy away from the detonation at the speed of light. And similarly, when two black holes collide, these gravitational waves will cause ripples in the universe. Ripples, all of you are well aware. Please throw a stone in the water, then automatically ripples will cause. Similarly, in the universe, ripples will be caused when a star explodes, when two black holes collide. And similarly, two neutron stars, I have already told you, neutron stars are formed after the explosion of stars. So, two neutron stars orbit each other very closely, and energy is carried away from the system by gravitational waves. So, gravitational waves are transmitted because of explosion of stars, because of collision of black holes, or when two neutron stars are orbiting each other in the near vicinity, right? So, these gravitational waves could not be measured for the 100 years. For the past 100 years, it became speculation. They could not be measured because of the sensitivity of the equipment. Einstein himself told that they are too feeble to be measured, and in his version, he thought that it may not be possible to measure these waves, but now because of scientific sophistication and because of the sensitivity of the equipments, now after 100 years, we developed perfect instruments for measuring these waves. And what was measured? Two black holes. One is 36 times the mass of Sun. The other one is 29 times the mass of Sun. Both separately have got 65 times the mass of Sun. One is 36 times, the other one is 29 times, and they are 1.3 billion light years away from Earth. And they were orbiting around each other, collided and merged into a single massive black hole of 62 times the mass of Sun. Initially, individually, their mass together was 65, but after collision, what happened? The combined mass came to 62 times the mass of Sun, right? As per the theory of general relativity proposed by Albert Einstein, the pair of black holes orbiting around each other lost energy through the emission of gravitational waves. That means this mass of Sun, when they are losing, will be converted into energy, and this energy is emitted through gravitational waves, right? So, as they lost energy, they were gravitationally drawn close to each other, and as they became closer, the spinning became faster, and which resulted in emission of more gravitational waves, and in the process, after the collision, their combined mass became 62 times the mass of the Sun. That means they lost mass of 3 times the mass of the Sun in the form of gravitational waves. And by the end of 20 milliseconds, final collision and a dark violent merger took place. This is all about the thing what was measured by this LIGO experiment. What is LIGO? LIGO is a Laser Interferometer Gravitational Wave Observatory. 2 LIGO instruments were installed in Louisiana state of America and Washington state of America, and they are 3000 kilometers apart. What was the need of 2 LIGO instruments? Because if you install 1 LIGO instrument, then that may be affected due to local disturbances. Local disturbances may affect 1 LIGO experiment, but if you install 2 LIGO experiments and analyze the waves which are passing through these 2 LIGO experiments, then the suspicion of localized waves will be lost, and both of them worked in unison, right? So, each of LIGO instrument got 2 L-shaped detectors with 4 kilometers vacuum chambers. When a gravitational wave passes through it, because gravitational wave, as I have already told you, they are ripples in space. Just what we get when we throw a stone in the pond. So, these are ripples in the space. So, because of these ripples, this 4 kilometers chamber will stretch in one direction and squeeze in other direction. Whenever any ripple is created, it will stretch in one direction and at the same time it will squeeze in other direction. So, this 4 kilometers long chamber, when any gravitational wave passes through it, then it will stretch in one direction and it will squeeze in other direction. And in this LIGO experiment, interference of laser as it bounces between different points, because this is 4 kilometers in length. In 4 kilometers length, this interference of the laser is measured. By this way, this laser rays can identify whether the space in between is squeezed or stretched. If there is no gravitational wave, this laser will transmit the signal in one way, but if there is a gravitational wave, the transmission of signal by the laser is different, right? So, this experiment measures the most violent events in the universe occurring millions of light years away, and the smallest measurement ever attempted by science was attempted by this LIGO experiment. What Albert Einstein thought at the time was that we may not develop an instrument to such a fineness, but the scientists developed the smallest measurement ever attempted by science, that is a motion 10,000 times smaller than the nucleus of an atom. So, now the measurement of motion 10,000 times smaller than the nucleus of an atom was attempted and measured by the scientists through this LIGO experiment, right? So, how does it matter? Finally, this gravitational waves because of the collision of black holes or explosion of stars. We are able to measure them, feel them on the ground with the LIGO experiment. And how does it matter to the science fraternity as a whole? First and foremost is it confirmed Einstein's theory of general relativity, which was published 101 years ago. Second is it gave birth to gravitational wave astronomy. Third important point is we can now observe collisions between black holes. The fourth important point is we can go back to map the era close to the Big Bang. When it comes to the universe evolved with the theory of a Big Bang, and we can map our theory, or we can go back to the period closer to the Big Bang, right? So, these four are the points which emanates out of this experiment of measurement of gravitational waves, and several Indian scientists are also associated with this project, especially two institutions, IUCAA Pune and ICTS Bengaluru are associated with this project. Third important point is it is a game-changing cosmic revolution. Fourth one is it is a case for Nobel Prize in Physics, right? Finally, we can say it is the beginning of a new era of gravitational astronomy, right friends? It is all about the cosmic revolution and measurement of gravitational waves. I hope you understood to some extent, as it is most complex topic, right friends? Have a nice day. Thank you.